Hello, everyone, and thank you for joining us. Today on the Dairy Signal, we're going to be talking about some of those cover crops that you probably have heard about, maybe tried yourself, but we're going to be talking about cover crops and how they may fit in your corn silage systems. But before we dive into that discussion here this afternoon, I have to start out today's episode with a big thank you to DLF. DLF is our current sponsor of the Dairy Signal, and I know we are on the 2nd of April, so we don't even have to say it's an April Fool's joke because it is sure not. But a huge thanks to DLF. Oh my gosh, I am screwing up my acronyms. DLF for their commitment to making sure that education that can get to you anywhere, anytime at your fingertips. So DLF is committed to supporting dairy producers and dealers with genetics and varieties they have come to know through the Dairyland and Pioneer brands. They're the exclusive supplier of trusted genetics and varieties acquired by Corteva's Global Alfalfa Program in 2023. They're dedicated to experts and salespeople focused solely on alfalfa. So, if you're wanting to learn more about them, make sure to head over to their website to see about how their alfalfa needs can maybe meet with yours. So, with all of that being said, we're going to actually dive right into things today here because apparently I'm getting tongue-tied. So we're going to throw it to those who are going to have a much better time speaking on a great topic this afternoon. And joining us here today is Dr. Matt Rourke, who is a professor in the Department of Soil and Environmental Sciences with UW-Madison and Extension Specialist, as well as Hannah Francis, who is a PhD student with UW-Madison. So thank you both for joining us here today. I'm excited to dive into the topic, but before we do so, Hannah, Matt, would you mind giving us just a brief introduction about yourself?
You bet. My name is Matt Rourke, right? So I'm a professor, but I'm also an extension specialist working in soil fertility, nutrient management, cover crop management, soil health, all that fun stuff. I also do a lot of work in the potato production system, and I currently serve as the faculty director for the Dairy Innovation Hub.
Wonderful. And now, Hannah, just a little bit about yourself.
Hey everybody, my name is Hannah. I'm a PhD student in Matt's lab, and I think a lot about nutrient cycling with cover crops for my research. So really excited to be here.
Wonderful. So I just have to say that I know it is a rainy Thursday afternoon here, at least in the Midwest. So if folks are watching live, you can definitely ask your questions for Matt and Hannah by using the bottom right-hand corner of your screen where you're seeing this video. There's going to be three little dots. And on that portion, you can click it and you can click the button there that says ask a question. And we want to hear from you. What questions do you have? Interact with this episode and make it yours, especially as this is very much an idea of what works within your system, what's worked here in the research that they have done. Ask away. So, throughout today's episode, ask those questions. With all of that being said, though, I'm going to have Matt, I'm going to have you take it away with slides here.
Awesome. Hannah's going to get them set up. We're in two different locations, but Hannah's going to be running the show here this morning. So,
All right. Are they sharing right now?
I see a nice corn stover field right now.
Yeah,
Okay.
we're on slide
Yeah.
two, but that's okay. Perfect. Okay, there.
There.
First slide, fantastic. We're talking cover crops, and we're talking about a very specific part of the production system. We're talking like post corn. We got corn silage harvest, probably got some manure being applied in the fall, and then we're going to plant a cover crop. So we're going to talk about kind of that window. And so, like the whole premise, right, is the next slide is we all know what a corn silage field looks like after harvest. So but it also provides an opportunity, right? So it's an opportunity to uh, apply manure. It's an opportunity to plant to cover crops, right? So on this slide is a picture of now coming into the spring. Half the field here had a rye cover crop planted, the other half didn't. So what are the obvious advantages here? Obviously, we have soil coverage. We have some nutrient uptake. You're going through the slides a little fast, Hannah.
Okay.
Yeah. Sorry. Right. So what are all the potential trade-offs here, right? Okay, so sorry. Hannah and I did not rehearse the queuing here. So this is now it's all falling apart. Okay, no, just go ahead, Hannah. You can go through the next slides. You click at a pace and I will keep up with it. And again, during this whole time too, as you're thinking about cover crops and your use of cover crops on your field, you got questions. feel free to type in. Amber's gonna jump in and stop us from rambling. Okay, so here's sort of the visual description, right, of like what's going on. So we have an opportunity, to put, we're talking about fall manure application. Yeah, just keeps ticking through them, right? So we're talking like, so there's a lot of pressure, right, in terms of like, okay, what are you going to do for water quality? Well, cover crops can provide that. They're going to take up nutrients. That's gonna go really well with the fall manure application, where you're putting out the manure, the nutrients, well in advance of any sort of crop uptake. High potential to maybe lose some nutrients. It's gonna keep it in the soil system. But the problem is, well, it's not a problem necessarily, but like what's gonna happen to your next crop? Are there some trade-offs with that crop production? And that's kind of been a big focus of my research and the research that Hannah's gonna show here next. But so we have this like if we go to the next slide, we think about this as a scale, right? We're going to have the benefits on one side and drawbacks on the other. And we want to have the benefits side be a lot heavier, so the benefits are outweighing any potential drawbacks to incur, for the use of cover crops to actually occur on the landscape. So let's go through a couple benefits. One is water quality. So I'm going to talk about stuff in general. So like what in general, what's going to happen? So, and I'm going to use a lot of research papers that we call meta-analysis papers. So these are like big review papers that go and try to find all the studies they could find. Like in this case, it was all the studies they could find using grass cover crops and how much it reduces nitrate leaching. And so in this study, they found 28 studies using grass cover crops reduces nitrate leaching by 56%. So right off the bat, you're cutting leaching losses by 50% just with using a grass cover crop. And the beauty of it is you didn't need that much biomass to do it. Once you got to kind of that 1,000 pound threshold, that's when the benefits really kind of kicked in. So you don't need to grow, 3,000, 4,000, multiple tons of biomass. Just getting a nice coverage with some biomass actually was showing, well, was getting a lot of benefit there. Then the other potential benefits, we're always interested in carbon and we're interested in soil health. Um, and so for soil carbon, that's a tougher one. There's not a lot of research out there. There's the basically in general, the longer the use of the cover crop, the greater the increase in soil carbon in your soil. But organic carbon and organic matter, you can think about that as a long-term gain, with long-term continued use of cover crops. Soil biology is perhaps more interesting. You might see a more immediate effect in some of these soil health metrics that we're interested in, which include things like the microbial activity in your soil, like how abundant are they, and how active are they in the soil. So there's another meta-analysis that has shown, like with any cover crop, but also with grass cover crops, use of grass cover crops are going to have a net positive benefit to your soil health. Okay. All right, so that's a lot of great stuff. And that's a lot of stuff that's for the water and for the soil, but what about for the production system, right? So are there potential drawbacks with your subsequent crop yield? But also what about nitrogen? So this is the big thing. The cover crops take up nitrogen. Okay, so we know that they're going to do that. And in a perfect world, they're going to take up the nitrogen, especially if manure has been applied. It's going to take up the nitrogen that was going to be leached out. And they do that. But they also tap into the nitrogen that was going to be available for that next crop. And so I am showing the worst case scenario and is going to show more modern scenarios. But this is a worst case scenario, a lot of our original cover crop work. So this is in our Arlington Research Station back in 2017. The top line in the blue, that's with no cover crop. And so this is manure's been applied, and I maximized my yield with 100 pounds of nitrogen. But when I grew that rye cover crop, this was like well over 2,000 pounds, close to 3,000 pounds of dry matter biomass, a lot of nitrogen uptake. I needed to apply um, over 100 pounds more nitrogen to try to make up that difference to maximize yield. And even then, within the context of the study, I couldn't quite make up for it. I still had a little bit of a yield drag in there. So this was sort of our worst case scenario. Very high seeding rates, um, perfect conditions for a lot of growth. So this was sort of like, okay, the worst case scenario. From then, we've done more work. Hey, let's ratchet back our seeding rates on the covers. We don't need to grow that much biomass. we've started to see less and less of that yield effect potentially. And there's been and I'll show one more slide here with this yield effect. There was a big meta-analysis that came out, and for the grasses, you can see basically on average throughout the studies, there was no big yield effect. So there's no net positive yield effect. There was no net negative yield effect. That said, there is some potential risk, especially with managing, especially in a no-till system, to make sure you have a really good no-till planter setup. That's probably the biggest risk. But the big thing that we can't seem to close is that nitrogen effect. So, in general, what I like to say, there's a price to be paid to the conservation gods, and that price is going to be paid in nitrogen. So, especially when you're using manure. So, with this, what it's really happening is you're putting out that manure in the fall and you're using a cover crop, and all it's doing is reducing that manure nitrogen credit. So, you just have to expect less nitrogen from that manure to be available because that cover crop tapped into it. And so what we want, this is our figure here, but what we want, you go to the next slide, we really want a figure that looks like this, right, where that yield drag is small. We can hopefully say that yield drag is not occurring, and then that greater nitrogen requirement is also minimized to offset that. And so that side's really light. The benefits outweigh the drawbacks, and we'll go from there. So next, I want to turn it over to Hannah Francis. She's been doing some great work. This is over the past few growing seasons. We're really dialing in that effect of the cover crop and the manure and those interactions and trying to really understand how consistent these effects are. And with that, I'm going to turn it over to Hannah to share some of her results.
Yeah, thanks, Matt. And I'll go through the slides at a less crazy pace. So, to dive into that drawback benefit balance that Matt brought up to balance our seesaw in the benefit way in a corded silage system, we have been conducting a multi-year study at the Arlington Agricultural Research Station, which is just north of Madison. And a little spoiler alert, what we've been seeing is that when you include a rye cover crop ahead of corn silage with manure, you're able to maintain those silage yields. But you're getting those benefits that Matt just talked about when you include that rye cover crop. And we all know that we want to keep that nitrogen, particularly that manure nitrogen in our system, both for those water quality benefits and because it's a really valuable fertilizer. It's providing nutrients to the system. And we know that that fall manure is particularly susceptible to losses in a silage system. You saw that bare field that Matt showed in that second slide. So how do we prevent that nitrogen, often in the form of nitrate, a really mobile form of nitrogen, from leaving the system? And like Matt mentioned, grass cover crops, and like that meta-analysis showed, grass cover crops do a really good job of keeping nitrogen in the system. And cereal rye is a particularly good overwintering grass cover crop that fits really well in Wisconsin's post-harvest climate. And because it's a grass, it takes up that nitrogen at a time when no other plants are growing. Okay, so we know we can mitigate these losses. We know we can keep the nitrogen from leaving the system, but what happens with our next silage crop? And until this study, really, we had some simple comparisons, but we didn't have great yield response studies comparing silage yields with different nitrogen fertilizer rates, with and without manure and with and without a cover crop. So we were missing those until now, and that's what we're going to share with you. So we set up field trials at the Arlington Agricultural Research Station, and I'll share the relevant agronomic information here for those curious. So this past year, we applied manure in October at a rate of 10,000 gallons per acre. We had an anticipated manure credit of 22 pounds of nitrogen for the first year. And then we planted a cover crop just a week later. We planted the rye cover crop a week later. And then we terminated the cover crop in early May. And by the time we terminated the cover crop, we'd accumulated just over 2,000 pounds of rye per acre, which meant when we analyzed our rye and did some calculations, it took up about 75 pounds of nitrogen. And so this picture is from that field just a couple of weeks before termination in April. And you'll see there's already a stark difference of what a field looks like with a cover crop and without a cover crop. Okay, so to test for those benefits and drawbacks, we planted corn silage with and without rye and with and without fall manure and fed that corn 8 different nitrogen fertilizer rates. And what we end up with is a yield response curve for each treatment. So down here on this x-axis, we have our nitrogen fertilizer rates. Here we have our silage yield, 65% moisture. These dashed lines show where the optimum nitrogen fertilizer rate is for each treatment, and this is the agronomic optimum rate, or where each yield curve begins to level off, where we've achieved our maximum yield. So these circles below correspond to each optimum nitrogen fertilizer rate, so those dashed lines. And so our lowest optimum fertilizer rate is the treatment with just manure, and then the treatment without manure and without a cover crop, then the treatment with a cover crop and with manure, and then the treatment with just a cover crop. So I want you to look at these curves and note that the darker lines, the treatments without a cover crop, these darker lines, they're a little bit flatter than the treatments with a cover crop. And we'll talk about that in a minute. And then the yields for each treatment are noted in these boxes at the top. So let's just talk about the manure treatment since we're often applying manure to these fields in the fall. So when we applied manure, our optimum nitrogen fertilizer rate when we had a cover crop was about 40 pounds higher to achieve our maximum yield. But notably, when we managed our nitrogen, when we achieved our maximum yield in each case, with a cover crop and without a cover crop, the yields were not different. We achieved the same yields when we included a cover crop in this system, which to me, this suggests that manure provides a buffer to this risk of yield loss when we use this rye cover crop. So you might be asking yourself, well, what would have happened if we had applied a little bit less nitrogen? What would have happened if we applied the same amount of nitrogen with the cover crop as without the cover crop? Which takes us back to our response curve. So if we look at these curves, if we took our yield at the treatment with the cover crop and we applied a little bit less nitrogen, the same amount as the treatment without a cover crop with manure, we only end up losing about 1 ton of silage yield per acre if we reduce our nitrogen by 40 pounds. And this is because our treatments without a cover crop, those darker lines, were not super responsive to added nitrogen. You'll note that here are our yields for each treatment. So our manure with a cover crop, no manure with a cover crop, the manure with the cover crop, and the no manure with the cover crop. We got high yields even with no additional nitrogen fertilizer. Why was that? What was going on in this dairy system in this field? So a little bit of field history for everybody. We love a little history moment. We had alfalfa in this field 2 years ago in 2023. This was followed by corn silage in 2024 before our study year now, almost a year ago, last field season. And we also had applied manure when we had the corn silage the 2 years ago. And when we think about having alfalfa 2 years ago, this implies that we might have had an alfalfa credit, which was alone about 50 pounds of nitrogen per acre. So when we think about our alfalfa credit, which then we tested the soil the fall before we started our trial, we confirmed that we had a lot of nitrogen in our soil already when we were starting this project. And so the response curve suggests that we had high residual nitrogen, and without a cover crop, our fields we didn't have a lot of yield response to adding more nitrogen fertilizer. Meaning when we added more fertilizer, we didn't get substantially different yields when there was no cover crop in the system. However, when we added a cover crop, we know that rye takes up nitrogen. We know it took up about 75 pounds of nitrogen during this study year because we accumulated about 2,000 pounds of biomass. But that difference isn't quite reflected in the optimum N rate differences for each treatment between the cover cropped and non-cover crop treatments. So What this means is, like Matt alluded to before, we reduce that manure nitrogen credit in our manured systems, and the rye might even be taking up a little bit more of that nitrogen, but we didn't need to add 75 pounds of additional nitrogen fertilizer to achieve our optimum nitrogen yields, to achieve those maximum yields with the cover crop. Similarly, in the non-manured system, we needed to add just we needed to add even more nitrogen to achieve our maximum yields, but not quite that full 75-pound amount. But we did have a little bit more of yield risk without the manure in the system than when we had manure in the system.
So, Hannah, I'm going to jump in real quick
So,
with a question, if you're okay with that.
yeah,
Okay.
absolutely.
One of the areas that I want to make sure, because as we're going through, we're using some terminology, including like alfalfa credit when it comes to nitrogen, manure credit when it comes to nitrogen. We never really addressed how exactly is that on a very high, quick level, because I know things can go very in depth very quickly. But just for a quick reference for those who are wondering, how is that calculated or thought about when in terms of figuring out not only the nitrogen that you currently have in your system, but moving forward as well when we're talking about cover crops, manure, and in this case, or in the slide before, alfalfa.
Yeah, this is so we get these values usually from like the A2409, and these are recommendations that come from years and years of field trials that have been averaged over the long term. All of this data has been accumulated, and people have looked at, okay, what happens when we have manure and when we don't have manure? And they do all these yield response curves. And then they say, okay, how much nitrogen can we reduce when we include manure in the system? Or what do our yields look like when we have alfalfa? How much nitrogen do we need to include versus when we don't have alfalfa? And they make those comparisons. Matt probably can probably explain this a little bit better.
Well, at the end, we say, generally, if it's your first year following alfalfa, it's probably a 90 to 180 pound credit, like meaning that it's basically a fertilizer equivalent. So if you follow alfalfa, it's like you're following a large application of nitrogen fertilizer. Second year, though, we think that alfalfa is supplying 50 pounds of nitrogen. So that alfalfa is still giving nitrogen because it's in that organic form, right? So it's still doling out nitrogen about 50 pounds in that second year. And so that's kind of what kind of drove some of those high yields that Hannah saw when at the low nitrogen rates. Manure is a little more complicated. We generally say we know you get your manure analyzed, you get a total amount of nitrogen in the manure, right? But then we say, well, only a percent of it's really acting like fertilizer would. And that's the amount that you can count being on there. So generally anywhere between 30 to 50%, a little bit of adjustments based on application rate.
Okay, thank you. I think that is helpful in just making sure that we're all on the same level
Yep.
when we're talking about it because, gosh, I know everybody's probably thinking, this sounds wonderful, but I know that over time it always changes, and that's the
Right.
fun of a dynamic system.
And we call it a credit, but it's really a credit because we're talking about like a nutrient management based approach, or it's like an accounting based approach. So it's all these credits you take before you ultimately decide how much you want to quote unquote pay in nitrogen, right? How much nitrogen do you need to actually apply? So that's why we refer to it as a credit. Yeah.
Perfect. Okay, Hannah, I'll let you keep going on for now then.
No, I think you asked that question at a really great time because our big takeaways basically are that, you know, these trade-offs, do these like benefits outweigh the risks of including a rye cover crop? This kind of big question that we started with. And I think what our data are showing, what our field studies are showing so far is that in a silage system with manure, including a rye cover crop in that system, is not hurting your silage yields. And what you might need to do is think about making up for the reduction in your manure credit, so that um, anticipated reduction in nitrogen that you might think about incorporating into your nutrient management plan, you might need to apply a little bit more nitrogen when you include a rye cover crop in the system. And because Matt mentioned this idea of the cover crop building, like alfalfa, building sort of this reservoir of organic nitrogen in the system, That's also kind of what rye is doing. While that nitrogen is not immediately available for your next crop, what it's doing is building this really important reservoir of soil organic matter and these reserves that not only build your long-term soil health, but may eventually, over the long term, be able to provide nitrogen to your next crops over the long term. And so those are the main takeaways we have for you today. And I'm getting into the field next week to start setting up year 3 of the study. So excited to share that with you all in the future for sure.
Okay. Well, I definitely have we had a question come through, which I appreciate, and it's an interesting one. I've got some questions here myself for folks watching. You most definitely can ask your questions as well. But the first one that I probably could have asked, or maybe should have asked right away in the beginning, is that this is just grasses, or thinking about it in terms of rye. Why was this the cover crop of choice versus something like legumes or brassicas? Because they all fit in different parts of the system. So bear with me here, and I know the surface level, I don't know the very
Sure.
in-depth. So why was rye the cover crop of choice for the study?
Well, it really just comes down to planting date and how much biomass will grow. The legumes, I love legume cover crops. Hannah does too. She worked on legume covers during her master's time, but they need more time to grow. And so by the time like to have that window, especially when you get into October, some people have had success with legumes, but consistently rye is generally the one that's going to grow quickly, provide that coverage. So this focus entirely on rye. The brassicas we've studied, those generally do better. You got to get them planted a lot earlier, at least a month or so earlier. So those fit really well after a winter wheat harvest or something like that, or some like late October. It would be a good time to plant those. Legumes, you just they need to get going a little bit larger. The benefit of the legumes comes through, they're going to provide nitrogen, right? It's going to be this opposite effect, but it's a biomass game. So the idea of like you got to get enough biomass, and a later planting means you're probably not going to get enough biomass, or you got to wait longer in the spring to keep letting it grow to get that benefit.
Okay. One of the questions that came in here and it reads, how much does rye termination time impact the nitrogen availability for the next crop?
Ooh, okay. So a couple angles on that, right? Time of year when it could be terminated, or time relative to the time of corn planting. So, and I guess, I don't know, Hannah, you can chime in too, but I think probably that probably doesn't matter as much as the total amount of biomass at the time of termination. That's the key, right? So we want that sweet spot is to keep it to, try to get at least 1,000, half a ton of biomass. You don't need more than a full ton of biomass. Keep it in that sweet spot where you're going to have those water quality benefits. So that's going to matter more than the actual timing of the termination. But we also, in our studies, have always terminated 7 to 10 days, uh, or plant the corn 7 to 10 days after the termination of cover crops, because that's what the weed scientists told us to do. This is a so get into arguments with my colleague Rodrigo Worley, but now he's saying maybe there's some interesting things you could do with planting green into this and all those kind of cool things. So we got to maybe question our assumptions on that as well. But that's just generally what we've done.
Okay. One of the other sides of it, when I think about not only timing, but depending on the year that we have, I think about the weather. And some years going into fall and spring, it is wet, and I mean like wetter than wet. And we've had a few of those in the past, not too many years here. So when thinking about that, how does certain times of season or weather impact, this whole system that we're talking about here today? Because we all know it can.
Yeah, I mean, I'll jump in real quick with that. I think one of the benefits of rye is that I mean, it takes up water. It's a growing thing at a time when nothing else is growing. But that conversely can be consequential if you have a drought year. So you might want to think about terminating even earlier if there's sort of this risk of drought ahead. Yeah.
Yeah, I always suggest try to make sure those fields get prioritized to terminate early. I mean, some people have the goal of like they want to grow a lot of biomass and they want to really push the system like that. The trials that we've been running, which are on like our experiment stations, but we also have a lot of trials on farmer fields, demonstrate there's kind of that sweet spot where stuff's minimized, because once you get, not only is a bigger cover crop taking up more water, it's also taking up more water deeper in the profile, right? The roots get deeper. And so we know that like once you go with bigger biomass, you have less nitrate and less water maybe into maybe that second foot of soil. So I'm more concerned with that sort of risk. But it does create problems, right? It is something to manage in the spring. So if you have a wet spring and you can't get out to that field, and does that cover crop get away from you? Yeah, that is possible. So just things to keep an eye on. Another thing you could try, an entry level, doesn't have to be rye, right? Oats and spring barley will winter kill. The real trick on those is again, it's a biomass game to get any benefit. You still need to have a fair amount of growth in the spring or fall to get some sort of erosion control with the dead biomass in the spring. But it's a nice entry one to kind of if you're looking to just play around with some covers and not have to worry about anything in the spring or not have to go out and spray anything. Those could be some covers, especially if you can get them planted early.
Okay. One of the other questions, and this is me with my producer hat on. We are in an interesting time within the economy here when we're thinking about not only that cover crops have a lot of benefit agronomically, and especially as we were looking at that scale or that balance that you had earlier, it has a lot of benefits, especially when done right. But when talking with or thinking about on the producer side, if somebody's trying to get into it, but really wants to try and minimize the risk of quote unquote failing. Some,
Mhm.
it just not working right or all the big challenges. Um, Especially when adding something like rye, what are some of the biggest takeaways for producers who are deciding whether or not to add it into their management practice? Because it might be somebody on the fence out there. What are some of your thoughts there?
Well, I mean, I would say that it depends. So it gives you a little more. How do you want to say this? When you're putting out your manure, right? What are you really crediting, or how much do you really expect to be there, right? And so uh, the there is a cost to it, right? It's a little bit of a hidden cost, right? But if you're already kind of pushing the system a little bit anyway and looking to cut back, this kind of you could think about you might be able to cut back anyway with using your manure. That said, the big thing in a year like this is you cannot let it get out of control, right? There can be significant nitrogen penalties but we're talking like completely out of control. We're talking, hip high, you know, uh, rye biomass, right? That is not what we want. Sm Slow and steady wins the race here, right? We want coverage. And that's the way to go. So that's why I even like terminating it super early with just 1,000 pound, like just some coverage might be the best thing to do. That's going to minimize that nitrogen effect, right? So we're looking at like Hannah's data that she's showing, and most of the things we're showing are like it's a decent amount of biomass because you can certainly put on a lot of biomass when we're planting it in September. But maybe you plant a little late, you cut back on your seeding rate. You could even cut back to even like 30 pounds. We've had some really good success with getting really good stands at that low of a rate, 30 pounds per acre for seeding rate of rye. So cutting back costs like that, terminating early, keeping the biomass low, you get the conservation benefits, get the water quality benefits, and you've minimized any the drawbacks, right, on that one side. You've kept that side really light.
Okay. Next question we have from a listener, and it's about soil type. How does it impact in things like the research study you've done in terms of nitrogen and yield?
Yeah, I mean, we are operating in a silty loam soil and probably one of the best soils that you could grow any type of crop in. It has a relatively high organic matter and a high capacity to accumulate organic matter. And so, yeah, I think that's important when you're thinking about how are we building our organic matter over time and what is the capacity for our soil to build and retain organic matter and also to retain water when we're thinking about a cover crop. So in a sandier soil, you might want to think about, okay, do I have enough water to have this cover crop be successful and have my next corn crop be successful if that's what you're growing. Those are the things that I think about, but this we're operating in one soil type in this study. I mean, obviously, I would love to test this in all different soil types throughout the state.
But I'll say we've done other trials, mostly looking at corn
Yeah.
grain responses, like some of this on farmer fields, and a lot of similar, very similar effects where we see this nitrogen gap that needs to overcome. Irrigated sands are a different story. We generally see no effect. Nitrogen response curves are generally right on top of each other. We think that's due to obviously you're irrigating, it's not water limited, and I think everything just sort of decomposes a lot faster on these sandy soils, irrigated sands. So not as big of a no real detrimental effects we've seen on sandy soils.
Okay. As research continues in this area, especially in terms of cover crops in general, do you see that nitrogen recommendations evolving, or how do you see that evolving in terms of what producers should be thinking about or considering when it comes to their soil types and what they plan to be getting out of it, especially on a corn silage system, because it does take a lot out of the soil.
It does, and that sorry, I mean, and Hannah can talk like this is like we don't have a lot of nitrogen response trials on corn silage. So this is actually her results are actually really fantastic in building some response curves so we can make better recommendations for corn silage, which certainly are showing that are much higher than corn grain, right? So I think we need to that needs to be acknowledged here.
Yeah, I think this is research is filling a gap that we have in our nutrient recommendations, and part of the study does compare what these nitrogen recommendations look like compared to corn grain. And it one of the interesting things that we're seeing with the study is that in a corn silage system, the risk of including a cover crop is less than in a corn grain system. The the difference in optimum nitrogen fertilizer rates when you include a cover crop versus not in a grain system is much larger. The difference is larger than in the corn silage system. It's smaller.
Interesting. Okay. Now I know you guys are still going on, it sounds like, with this research. What's next with it? Where is it yet to go, and what's yet to be researched on this particular area?
So many exciting things. So we're repeating this, we're repeating the same exact study, and it's already all set up for this coming year. On top of this study, we're doing some really interesting work with the rye cover crop. The question that I've gotten all the time from farmers, from producers, is what happens to that nitrogen from the cover crop after you terminate it? Where does it go? Does it become available to your next crop? What's going on with it? So, what we're doing is putting a chemical tracer on our rye. We're using a fertilizer that's specially labeled with something called 15N with a little heavier form of nitrogen, and we can study that in the soil. We can trace that in the soil and see where it's appearing in the soil. And we've been increasingly thinking about soil organic matter as having more stable pools and faster cycling pools. So I'm thinking about where that nitrogen from the cereal rye is going, how long it's staying there, and when it's uh, becoming coming into a plant available form for the next crop.
First off, we love scientific repeatability. But also, that sounds really fascinating. That is a wonderful question that, yes, I feel like every time I have these discussions, it's always one of them that comes up. And every time somebody's like, well, we have yet to figure it out. We can make good guesses, if you will, but we have yet to really dive into that. So that's exciting to hear. I know that I also want to ask right before we conclude here, is there anything else that in this area that folks should keep an eye out on? Maybe not necessarily research that you guys are just doing, but other areas, if they're interested in cover crops or even silage, and how cover crops interact, that folks might need to keep their ear to the ground on.
Well, really, the big thing is the use of these of covers for potential weed management, and so I think a lot of folks probably on this call have probably heard a lot about that and seen some stuff. So one of the big things that we've tried to do is we've got a bunch of different people doing research on covers, and we've got all sorts of differences of opinion in terms of how much cover crop biomass do you need for what benefit? For erosion control, for nitrate leaching, to minimize the effect on the next crop, but for how much do you need for weed control? And so we've got some really great extension publications out there that try to synthesize this kind of stuff. So you can kind of decide what do you want to grow that cover crop for, and then we have some nice guidance on like what how you should try to manage that cover crop.
Well, that's exciting because I know that it feels elusive and sometimes a little scary to get into it some days if you're like, well, there's all this information, but nothing's really condensed down. So that sounds wonderful. One last question for you both here today, though. When thinking about cover crops, the discussion we've had, and really thinking about the producer on this, what is one or two key takeaways that you want producers to be thinking about or maybe actively doing after today's discussion?
Yeah, based on my research, I think the takeaway is, if you're applying fall manure, throwing a rye cover crop out there is a great way to keep nitrogen in your system and to keep that manure and nitrogen from leaving your system. And it works really well. We haven't seen a yield detriment to the silage, so I think go for it.
No, I agree. It's a great system. It's a great system that provides that has some risks and opportunities, right? So, um, the also the crazy thing about fall manure is like we talk about, oh, the manure nitrogen credit, like it's a roughly 50% of the what you apply, but that number can be widely variable depending on how much it rains over the fall or into the spring. So having that cover crop there will more likely it's gonna keep that, just like Anna said, it's gonna keep the nitrogen in your system. And you do it consistently over time, you're investing in your soil.
Oh, wonderful. I have to say thank you both so much for being here this afternoon. Excited to see what's yet to come from the research. So we'll definitely have to have you guys back on once that gets more underway, and all of that side of things. So appreciate your time here this afternoon and joining us here today.
Hey, thanks for having us.
Thanks so much for having us.
I also have to say a quick thank you once again to DLF for being our sponsor for the month of April on the Dairy Signal. And if you are also somebody who's wondering what's going on with PDP and our workshops that we have coming up, we have our Smart Dairy, which is AI, and that's the artificial intelligence version of AI that we'll be having here in just a couple weeks, in I think Chippewa Falls. And then when there's one on the east side of the state, which I don't have right in front of me. So head over to our website to learn more and to confirm where that second one is at there. But for now, thank you for joining us here today, and we'll see you here next week on the Dairy Signal. Bye now.